Hello, and welcome to the Six Figure Developer Podcast, the podcast where we talk about new and exciting technologies, professional development, clean code, career advancement, and more. I'm John Calloway.
I'm Clayton Hunt.
And I'm John Ash.
With us today is Felienne Hermans. Felienne is a scientist working at Leiden University as an associate professor. Her book, The Programmer's Brain, is out now as a Manning Books early access program. Welcome, Felienne.
Hi, welcome to the show. Thanks for joining.
So, Felienne, before we get started into the meat of things, would you kind of give our listeners a little bit of background on yourself and sort of like how you got into computer science?
Yeah, absolutely. I think I sort of had this traditional pathway into programming, at least traditional for like children from the 80s as I am, that from the moment we had a computer in my house, I was like obsessed by that machine. And I only wanted to do programming and figuring out how it works and stuff like that. So even in high school, I continued programming. I was lucky enough that my high school had a computer club that I could join to hang out with other computer nerds. And then I went to university to get first a master's degree in theoretical computer science, and then I switched over to software engineering. I got a PhD in software engineering, and then I started working as an academic afterwards.
So now you're a professor. What are you teaching?
So one thing I teach is Introductory Programming. I think it's really the most exciting course you can teach. So, some professors, of course, like to teach more the advanced material, which also has its own way of being interesting. But for some students do not have this experience of programming in a high school or when they're kids. So they come into university and they really don't know yet, right? They haven't seen the magic of programming. So I think it's pretty cool to teach this first course to students that some of them have some experience maybe in other programming languages, but also many of them don't have any programming experience yet. And then it's like, oh, look at this, these little scripts that you can use. We do like very simple things, of course, like you have a Shakespeare book and then we count occurrences of words. But just this idea of imagine doing this by hand, and now you have this machine and it can do basically everything you can think of. You can automate it with a little bit of programming. So that's one course I teach that I'm super excited about.
Very cool.
And you're currently working on your book, The Programmer's Brain. Is that correct? It's through the early access program. It looks like there are several chapters out now.
Yeah, I think there are 4 chapters already published. I've already written 9 out of 13. So from my perspective, it's a little bit more advanced than people can already read. And then the idea is that we drop a new chapter every month or so people can continue reading and also giving feedback. So we've already gotten some feedback from people that are early readers. And then the paper book is supposed to come out somewhere in spring.
Okay. And when I hear the term programmer's brain, that makes me think that is that an affliction? Is that something that needs to be addressed by your medical professional, or what is the programmer's brain?
Like, oh, we're so sorry, sir. You seem to have a case of the programmer's brain. I don't think there's much we can do anymore.
Pretty sure that's what I've heard before, so.
Yeah. It is more that the book tries to explain what happens in your brain when you program. So most programmers, of course, have a really deep understanding of programs. They have a deep understanding of the computer. But most computer science programs, including the one where I teach, they don't really cover stuff related to cognition. So just like that cognitive scientists would consider basic things like the difference between long-term memory and short-term memory and working memory. That's not something you necessarily learn as a programmer. And maybe some people are like, you don't really need to know this. But once you start thinking, especially of reading code and understanding code that you haven't written, then it's sort of important to understand the difference between this code is hard because my long-term memory is weak here, and this code is hard because my short-term memory is suffering here. And the book tries to explain the basics of cognitive science and how that matters for reading code.
So I read the first 2.5 chapters recently, and one of the things that I found interesting was how easily you made me stop and go down a rabbit hole on the internet and look up how to do something. You chose to give some examples, at least in the first couple chapters, in 3 different programming languages. And while I'm familiar with several programming languages, I had never actually seen the APL programming language. And so that first coding example that you give in that, I was like, huh? What? And I had to stop. And later on in the second chapter, I believe it is, you actually have an exercise for the reader to go and do something with that language. But in the first chapter, when I first saw it, I had to stop. I had to go on the internet. I found a website that would actually run the code. I ran the code. I played with the code. I changed things. I literally couldn't move forward in the book until I had figured out what that code did. And I don't know if you intended that, but that was the side effect that I experienced. Was that part of what you might have been going for, or am I just weird?
No. So it wasn't like I meant to send you off on a hunt. But firstly, the reason that I picked APL is because I wanted to have a language in which the keywords were really where everyone would go like, what the fork, right? What is this? And it's really hard because the book isn't for Python or for Java or for JavaScript. It's basically a generic book. So if you want something that is actually real code, but also confusing to everyone, then there's not a lot you can pick from. Even something old like COBOL or Fortran, and there will be people that know that. Whereas with APL, it's like super, super confusing, and it's confusing in an interesting way, exactly as you described. So it is confusing because for people that don't know, and maybe they have now stopped listening and also Googling APL, but if you're still here with us, then every keyword in APL is a symbol. So something like a top or a bottom. They even have a keyword that looks a bit like an angry face, like this, like a weird smiley. So that's really, really weird. So the reason for that was really I wanted something that was confusing to everyone. But in the course I teach, so I just said I teach Introductory Programming. In addition to that, I also teach a grad level course called Psychology of Programming, which basically is the lecture notes of this course became the book. And then in the course, I devote an entire lecture to explaining APL, just because it is so different from everything that students and also many professionals know, that it sort of widens your let's say your overton window of what a reasonable programming language is like, oh, this is what programming is, and then there's APL like all the way over there, and you're like, wow, is this a programming language? How? And an interesting thing also is, of course, that it's very old. It's really from 1960 or something. So it predates many things that we all consider programming languages. There's some history there as well. And so some small things, like I first learned APL and then I did some R, and there's a bunch of things in R, like being able to reshape a vector, where I was like, oh, I know this from APL. So there's some mild usefulness even there, maybe.
So you're the one that understands both APL and R then. So when we have that problem, we know who the expert is. We can come to you and you can help us muddle through that correlation or that translation.
Yeah.
So I was kind of curious, how did you kind of go into how did you sort of find yourself investigating and learning and understanding and being sort of drawn into this idea or topic of sort of the programmer's psychology? What really brought you into to delve into that?
Yeah, that's a great question. So what mainly brought me into that is, so first I already had a love of programming and a deep interest in many different programming languages. So that was there. And then I started to teach, and not just at the university. I also started to teach children. I volunteered at a community center for years, where every Saturday I would teach relatively young kids, like 8, 9, 10-year-olds. I would teach them programming. And an interesting thing there was that sometimes they just wouldn't remember. Like they come on Saturday and they do some stuff, and then the next Saturday I was like, hey children, remember the for loop? And it was like blank stare. No, I don't remember. I was like, but I explained this to you like one time 7 days ago. How do you not remember this? This is very weird to me. Yeah? And of course, as an expert, something like a for loop or an if statement, it's just very easy. So how wouldn't you remember this? So I think I was mainly failing at teaching. And then I wanted to know, like, why am I a bad teacher? Like, I think I was Googling, like, why am I a bad teacher? Why don't my students learn anything? And then quickly you run into learning resources about all sorts of cognitive science related to teaching that very often also talks about what is learning? What is teaching? The idea of teaching is that you get knowledge from your brain into the long-term memory of whoever is learning. That's your goal. So if you don't really understand how long-term memory works, then how are you going to teach? So then I set out on this hunt for understanding how to teach. And then many of the things I started to see was like, oh, but this also relates to stuff that we talk about in the book, to design patterns. Oh, but this also relates to code smells. Oh, but once you know how the memory of people works, then you can make better variable names. And all of these things that I already knew, and that some of these things I had researched as an academic, I was like, now I understand what I saw in all of these papers. So this is at that point, of course, I didn't say, oh, let's write a book about it, because I really didn't know enough yet. But at that point, I did think this would be a nice addition to the curriculum. It would be nice if at the grad level, where students have been exposed to a number of different programming languages, we talk about what do those programming languages do to your brain. For example, imagine you are familiar with something that looks like a Java-like language or a Python language. Just visually Java with all the curly brackets and Python lacking curly brackets, but mandating you to put spaces in the right place. It's hard to imagine that in your brain that would be processed the exact same way. There must be a little bit of difference on how people read and perceive those languages. So then, as I said, I teach that course. I taught it for four times, and then I thought, okay, now I have this storyline. And of course, on every iteration, I was learning more. I was getting new papers. Students were, of course, also participating and saying, "Oh, we should look into this." So then I had this series of lecture notes, for which I thought this might also be useful for professionals and not just for grad students.
So in that research and in your lecture notes and in your lecturing and speaking with students and getting feedback from them on how well that's coming across, on how well they're able to retain that information, do you find that is there a commonality between those that are able to retain the information or able to come up to speed on new and different programming languages, new and different paradigms, design patterns, etc.?
Yeah, so you're saying, like, is there a sort of a brain that is more the programmer's brain, and are other people not able to do programming? Yeah, it's interesting, because sometimes you think that a certain person isn't like smart or made for it. And this is, of course, sometimes true, but very often it's also the case that they just lack knowledge. So it isn't that they're just not smart, it's that they just don't know anything. And like one of you with the APL language, you just really have no clue, even though you are capable of programming. So sometimes differences between languages can be so confusing. For example, if you already know Java and then you go to Python, I came from C# to Python, which is sort of the same thing, then it's like, oh, this is familiar. I know classes. I know methods. This is easy. I know fields. And then in Python, you're like, oh, but I want to put a field on a class. So you want to go to like the definition of a class to put the fields on the class. And then this isn't there in Python. You have to put the fields there in the constructor. But you're like, I can't assign to this field because I didn't define it yet. So things you know are not the things you know. And then it's not because you're not a good programmer. It's just, and at that point I was like, and luckily my partner is also a programmer and he was familiar with Python. So I was like, babe, what is going on? I know programming. I know C#, but this isn't object-oriented programming. So I think very often when we think people aren't like maybe made for programmers, and this can be true for students, but also for like juniors in your team. Very often it's related to the long-term memory, just to knowing stuff. And like I was saying to these 10-year-olds, why don't you remember a for loop? Maybe if you're onboarding a junior developer, like how much time you spent really taking them through the code base and all the relevant domain concepts. Probably you're just like, oh, welcome, Greg. You know JavaScript, clickety, clickety, click. Let's fix this bug. And then Greg might be an excellent JavaScript programmer, but he doesn't know what is the difference between an order and a shipment. And he doesn't know that this is healthcare, so there isn't clients, but there's patients, but it is the same type of thing. So you might think after 6 months, like, oh my God, this junior, like, oh, help, why did we hire him again? And yes, I mean, sometimes people are, not great programmers. It does happen, or maybe their mind is somewhere else. But very often it's also just that they haven't been exposed enough to the relevant domain knowledge or the relevant programming concepts.
Yeah, I find often that when trying to introduce someone brand new, no exposure to programming, it's a matter of finding the items that click with them, that really do break down that knowledge barrier, break down that thing that is blocking them. And really it's just a matter of finding what you can equate certain principles to, and then put it in a language that they already understand, that they already know. And then does that help form that association within their brain?
Yeah, definitely. So we have an entire chapter in the book about mental models and something that we call notional machines. And notional machines are examples that you use basically in daily life to explain concepts in programming. So there's really this equating I think you're talking about. And something I use, for example, is parameters are a backpack. So you're in the method call and you put all the parameters in your backpack, and then you travel to the method definition. And what is there in your backpack? Oh, it's the parameters. Now you take them out. So you're starting your parameter picnic, and these are the values that you have. And that's a concept that sort of people understand, like putting something in a bag, going somewhere, and taking the stuff in your bag out. That's more tangible, more relatable than the execution pointer is taking stuff from the stack. It's not because they cannot understand, it's just they don't know these words and they don't really have an understanding how that works. So definitely trying to equate stuff in programming to things like from math or from everyday life that people already know, that is a great help, because I already have a mental model of storing something temporarily in a container and then taking it out. It doesn't take me effort because this is something I am already familiar with. This principle is in my long-term memory. So then I can use it with ease. It's still hard. It's not that it magically makes all confusion disappear, but at least some part of the problem will be somewhat familiar to me.
And I guess over time, we sort of shift our models as we become more intimate with what's actually happening, like you're talking and using those other words. Maybe this is why some people say that I like to learn by doing, because by doing they can see the result, the causal effect of their actions, and then that actually gives them a model right there, a basic model to understand in the future. And if you've been doing this for a while, then you have a lot of instances of that causal and effect relationship. So thinking about that model is very natural.
Yeah.
In the book, there's a story about chess where somebody, I can't remember the name of the individual, but they were doing research on chess masters versus people who were good but kind of average at chess. And the biggest difference that I remember from the story, I could be wrong, but the biggest difference that I remember was that the chess masters, the bank of knowledge that they had available to them in their long-term memory was made up of larger groups than the bank of knowledge that the average chess players had. The average chess players had the board, right? So like C9 or, whatever. I don't even know how you label a board in chess, but
yeah, you do that like an Excel sheet.
Yeah. And then like the, the chess pieces. So knight, rook, queen, king, that kind of stuff. So knight at C9, and then trying to not only reconcile the shape of the board, but also the next 3 or 4 moves that might happen becomes more difficult because you can't process all of that information in your short-term and working memory.
Yep.
Whereas the chess masters, they could look at the board and go, oh, it's the queen's gambit, or it's the whatever, and okay, except for this piece is over here. So how can what's the next 3 moves from the queen's gambit with this piece over here? And they can move forward. Can the same thing be applied to programming? Is it, like you were saying, it's not that somebody is dumb or that they're not good. It's maybe that they need to build up those larger groupings. You mentioned, I guess, later chapters, there's something about programming models and design patterns and stuff like that. Now, usually we're taught design patterns as a language, a way to communicate what the code is doing or what the code could be doing. But it sounds like the suggestion from that story might be that not only does it help you communicate faster, but it also might help you predict the next few things that the code needs to do or that the code will be doing, so that when you're looking at the code, as soon as you recognize that pattern, you can translate the code faster and get past that line-by-line reading, trying to figure out what the code is doing, where the problem is, why it's off by 1, yada, yada, yada.
Yeah, there's actually an example in the book as well. So firstly, it's a great summary of the chess work. That's indeed very true. The guy that did it was Adriaan de Groot. He was a Dutch mathematician. So he was supposed to write a PhD thesis on math, and then he sort of accidentally stumbled upon this cognitive science idea that you described that's called chunking. So what the experts were doing, they could chunk a board. So they look at the board and indeed they just see, oh, this is Sicilian opening or the Queen's Gambit. So stuff from their theoretical knowledge, but also stuff from what we call their episodic memory. So stuff that happened to them in real life. So sometimes they might also think, oh, this was this match I did with Betsy on that rainy Saturday night, but with a rook in a different place. So they sort of had 2 different sources of memories that they could rely on. And indeed, this is very, very true for programming as well. Further along in the book, there's a study that German professor Walter Tichy did, in which he has people remember and understand and adapt code with or without design patterns. And then he sees that it is easier to understand, to process code that has design patterns, but only if you as a programmer really know the design patterns. So if you just have seen singleton pattern once in a lecture in university 10 years ago, then that's not helping. Like, I have seen Sicilian opening once, but I'm not a chess player. I haven't played chess in a decade. So it's not going to be helpful. It's only going to be helpful if you really have this good knowledge bank, as you say. So he did a study that we describe in the book, in which indeed a course in design patterns made people better at understanding code containing the design patterns, just because indeed, instead of looking at the code going, oh, you know, with this variable, oh, this is a counter, etc., they could just say, oh, this is a constructor. Oh, this is a singleton pattern. And that makes it a lot easier to process the code. And in a similar way, there's not really a concrete example of that in the book, but of course, as experts, we know that this also happens. Like with the 2 sources of memory, you can have knowledge that you have studied, like design pattern, but also sometimes, I'm sure this has happened to you, it has happened to me also many times, you look at code, you're like, oh, I used the pattern like this once. I once opened a database connection and then, you know, forgot to close it, and then somewhere else an error occurred. So you also have your episodic memory of having programmed for a very long time, where you can also look at code either from, oh, I know this as a theoretical pattern, or I know this as a disaster story from my youth, which is also going to be helpful in processing the code.
Usually those disaster stories from my youth end with, let me see who wrote this code. It was me. How did I fix that way back when?
Yeah.
No idea.
Yeah.
Is there anything... So it could all be broken down to something like, a book is a very useful thing to have, but only if you can read. So is there any way to increase our ability to read faster? Like, is there anything that we can do that will help us to remember these design patterns, or learn the design patterns, or learn, you know, because that episodic memory, that has to be built up over time. So you can't just like, jam it in someone's head like Neo. So how can we put those things in our head more concretely or faster than normal if we were trying to accelerate our learning?
Yeah, that's a great question. And we have some examples and exercises about that in the book as well. One of the very old techniques that you might know from second language learning is called flashcards. So you have these paper cards, and imagine you're learning French. Then on one side you put a French word, and on the other side you put an English word. And you're like, oh, what is a rabbit? Oh, lapin. And you just keep using those cards, and you can use them both ways, of course, from English to French. And apps like Duolingo, for example, are a little bit built also on this principle of translating little sentences and then building up knowledge. So these flashcards that you can just easily make out of actual paper or with an app on your phone, of course, those are a great help also in training your long-term memory in whatever you want to learn. So you can definitely put the name of a design pattern and an example of a little bit of source code on the other side. And then once you're, well, no one isn't trained now, but normally the train would be a good place to practice this. And on your commute in the train, you'd go like, look at the code. What is this? I know this pattern. And you look at the other side and you see if you're right, and the other way around is possible as well. You look at the name of the design pattern, you just think, what would be an example code? And then you flip it over and you see if you're correct. And it sounds sort of like a silly, boring exercise, but that does build up this knowledge really fast. And it is better than just reading a book on design patterns, because what you're doing there is called retrieval practice. And retrieval practice is really trying to remember something. So it's better to look at the name of the design pattern and really go, let's try to know it, even if you don't know, and then you flip it over. That is better. Science shows that has better results than just reading the book on design patterns a bunch of times. And now I'm giving the example of design patterns, but there's many other things that you could also do like this. For example, if you already know APL and you want to learn R, might not be a bit market for that, but it could also be, you know, Python and you want to go to Java. Write down all the concepts you already know in Python: for loops, if statements, list construction, list comprehensions, constructors, and then you write Python on the other side. And that might require you to Google to build your deck of flashcards. And then afterwards, you're just like, oh, I know this Java. What would the Python be? Okay, flip it over. That's just a really good technique. It's not like a magic bullet, like you're saying, I just beam the knowledge in your brain. It takes effort, right? Learning something, I have no better tricks than you have to work at it. But this flashcard technique has been shown to be really effective if you just want to get facts in your long-term memory.
It sounded like the key. Oh, go ahead.
Well, yeah, well, you go ahead. I was going to pivot a little bit.
It sounded like the key concept there was that accessing that retrieval element of the knowledge, that the flashcard. So I was kind of thinking of one of the techniques that we talk about is code katas, where you have to, solve a simple problem, but you're doing that over and over again. But you're trying to do that without having to, have your history of knowledge, which is basically exercising that same function of, I know the problem space pretty well, but I want to be able to practice learning that new concept, and might be a similar, basically to that flashcard style of what's going on.
Yeah, definitely. And some of the culture of programming makes this a little bit hard, because many people say, oh, if you don't know syntax, just Google it. So if you always have Google like at your fingertips, that means you're never trying to remember. Like the times I have looked up the exact syntax of how to define a constructor, it's many times. But then if you just not Google, if you just try to remember, at least even if you Google afterwards, just first really try your best and write down or type just what you can recall, because there's always like half, like, oh, it's a constructor in Python, well, I know it's in it. Or is it initialize? Well, it's something with underscores. Are they on both sides just at the beginning? If you just try to do this for a while and then Google and then practice a bit, then after a while you don't have to Google. And then some people, of course, will say, oh, it's just syntax, right? Oh, it doesn't really matter. But firstly, it really slows you down. Like Googling requires you to go to your browser. Then I'm in my browser. I'm like, even if I just look it up, you still see, all my browser tabs. Oh, there's a new email. It is super distracting. That's one thing. And also, again, about this working memory, if your working memory is occupied with looking for the syntax of something, then it cannot also think of, what I was doing is creating an instance of a method. So your brain is sort of wiped, and then you have to come back. And this is, I guess, a problem we all know. Also, if you're interrupted by a Slack message or something, you found your syntax and you have to come back, and it's always like, where was I again? Who am I? Why am I here? That also takes energy to get back. I have a whole chapter in the book towards the end about distraction and how much time it takes you to come back to your code once you've been interrupted. So just looking up the syntax, people pretend that takes zero effort because Google can present you with the answer with zero effort, which isn't even true. You go on Stack Overflow and people are like, why are you initializing a method in Python? Why don't you use Julia instead, which is better? So even if you could find the information in 1 second, which isn't always true, still for your brain, you have switched to an entirely different context. So it will take a little while to get back. So you can just Google it is not great advice, really, cognitively seen. I mean, it's great that all the knowledge is available on the internet, but it's also nice if you have some of that just readily available in your brain.
Yeah, I struggle with that myself quite a bit because I had heard that a couple of years ago that if you know how to find the answer or where to go to find the answer, that it's more difficult for you to truly know, retain, and understand the answer yourself. And there's also the challenge of just-in-case learning versus just-in-time learning. Like I had read books on Kubernetes years ago and retained nothing because I had no current project where I had to use the information. So when I'm trying to pick something up, I have to be practicing. I have to have a need to implement, to understand, to retain that information.
Yeah, that's very true. That's something else that we talk about in the book a bit, that is the consolidation of knowledge. So just facts, if you have to remember weird facts that aren't related to anything you already know, like Kubernetes might be not related to many things you already know, then you might be able to retain the facts if you really try with the flashcards, then it's probably possible. But then it doesn't click to hooks that are in your brain. So then it's just this loose knowledge that will fade away over time. Whereas indeed, if you use it in a project, you see different sides of it, and then it probably clicks to, this is like data storage. It's a little bit like this. And that will help you to retain the information better.
So in applying all of this, are there things that we should be doing or should stop doing? Sort of in our daily, I mean, we kind of talked a little bit about trying to think about it before we Google the result. But what might be some of those other practical applications that we could take away from this?
Yeah, so one other is using flashcards if you really want to learn new concepts or syntax. And one other thing that I really like is if you want to understand code that's really hard, then something you can do is refactor it to be closer to your knowledge. So we have this concept of transfer learning where you already know something in a certain context, but you don't know it in a new context. And what you can do is called hugging, which is bringing what you already know closer to what you're trying to understand. So for example, again, you're a Java programmer and you're in a Python code base and you run into something that's a list comprehension, which is really Pythonic way of manipulating lists. Then you might be like, what is this? And you can Google and you can read, and then at that point you probably understand the list comprehension. But it's still hard, it's still unfamiliar to you. So what I describe in the book is, it's a little bit stretching the definition of a refactoring, because what we typically mean with a refactoring is making the code better forever for everyone. But in this specific case, it might be better for you temporarily to take this list comprehension, focus on it, and just translate it into a for loop. Not forever, but just for now. Because then you can more easily focus on the rest of the code, because then you'll see the for loop, and this is in your knowledge base. That is easy to chunk because you've seen for loops many times. And then you can just have the code in this state for understandability temporarily. And luckily we have tools like GitHub, so you can have this version of the code where you just merge the whole code base and your version has the loops. This is doable. And then of course, after a while, you understand what all of the code is doing, and then you don't need these trainer wheels of the for loop anymore. And at that point you say, okay, let's roll back that commit, or maybe it's even better cognitively not to have the system do it, but then you're gonna say, oh, I take this for loop that I destroyed and made less readable according to some of my colleagues, and now I translate it back into a list comprehension because now I understand it. So I think that's a technique that is not commonly used because it's sort of frowned upon to make the code worse. People will say, oh, but now it's longer and it's more complicated. And then people that say that, you know, a list comprehension is always 100% better for everyone than a for loop, they don't really know or understand that if you are coming from a language that doesn't have list comprehension, which is any language, then it will be hard. And it's not that you cannot understand. Again, it's not that you are not a smart person. It's just you haven't been exposed to that specific language concept. So it will take you a little while. So I think that technique of temporarily refactoring code, which in cognitive science is called hugging, which is such a nice term. You hug the code so that it is closer to what you already know, like closer to your heart, closer to your Java heart. I think that's really a really nice technique that you can use if you're in a code base with unfamiliar programming language or unfamiliar language concepts. And then, of course, you might take a little bit of banter from your teammates that go like for loops. But that's okay, because it is, you are learning. You should just take that.
And Wesley has a good
Very
question in chat. He asks, so does IntelliSense hurt our long-term retention? I mean, IntelliSense, maybe even something like ReSharper that just a click away and it'll make it all better?
I think that's a great question. So it really depends how you use it. So if you use IntelliSense, in many cases you can use IntelliSense in two ways. Like I can extract a method, but I can also inline a method. So there it can be useful that I can have the code in a certain way that's a little bit closer to my understanding. Actually, inlining methods is also a technique that we talk about as a hugging refactoring, where if you have super complicated code and it has all these methods that you don't know, just inline all of it for now. Just click the method hub, take in all the code, because then you can form a complete picture of what's going on. So in that case, it can be useful because afterwards you can of course undo, but you can also roll everything back, maybe even slightly different than it was, but maybe now you found a bug or you found a solution or a better way to structure things. So there I think IntelliSense can be helpful, but indeed sometimes this has happened to me as well, where IntelliSense is like, oh, why don't you name this method that way? Or why don't you put this parameter? Like I'm extracting a message and then it has this extra parameter. I'm like, okay, IntelliSense, whatever, right? And then it makes the code into a certain shape that maybe it is even better, but it is more and more disconnected from the mental model that I have of the code, from the way I think everything is laid out. So that I think is definitely a risk, where you always want to be in this situation where what you think is where and how it is understandable, it is also actually in line with the actual code. So that I think is indeed a risk. But I love refactoring and IntelliSense as well. So I definitely wouldn't say it makes us less smart, but it is something to use with caution, because if you just sometimes click all the suggestions of remove all the code smells, then you might end up in a situation that is better by a certain standard, but not closer to what you understand, which isn't good.
So you mentioned that people would be able to read, even though the book is not fully completed out, but where might people be able to get that? And are there other resources you could direct them to kind of learn about this topic?
Yeah, so the best place to go, I guess we can put that in the show notes, is felienne.com/book. That has a link always to the latest version of the book. Of course, you can also go to the website of Manning, but that's also where my link takes you, and it's a little bit easier to find. So that's I would say the best place. There are, of course, many books that aren't specifically about programming. about cognitive science that you could also read. But then again, it does miss this connection to programming. And as one of you said about learning Kubernetes, it might be really hard to learn all these interesting things if you don't really know where it's going. So I would just say, wait for 2 or 3 months, and then you can read the entirety of my book. And no one has time to read in this pandemic. So if you buy it now, you can already read the first few chapters, and then by the end, by the time you found the time, there will be a new chapter left.
Awesome.
All right. I'm going to slightly rephrase my usual wrap-up question because of your background as a professor. So what has been helpful for your students or for your own career that you might share with other people who are just getting started, or maybe somebody who's just trying to level up their career?
Oh, that's a great question. So I think really to stay in the theme of the book and also in the theme of the whole episode, I think for me, the realization that sometimes it's not because you're stupid, it's just because you lack mental processing power, it's just because you lack long-term knowledge, has been really helpful for me to be kinder to other people and also kinder to myself. Like what I was saying about going from C# to Python, this was when I was already a professor. And then I was literally saying to myself, I am too stupid for this. I am too old to learn Python. My brain is destroyed by C++ or C#. I will never be able to do this. So then I was like really sad and angry with myself for failing. And in a similar way, I think more empathic towards other people. But even in a similar way, sometimes I've been in a situation with students where I was like, man, I've explained this to you 10 times and it just doesn't stick. How did you get a high school degree? Why are you here? Why are you here? Why did you think it was a good idea to choose a career in computer science? And in both those situations, it wasn't because I am stupid, the student is stupid. It was really just because coming from a different programming language into a different programming language is so hard, because it is like you're in this desert where you're like, oh, look, a palm tree, it has water, and then it's a dragon. It is terrible. It's even worse than learning your first language, because you think you're like, I'm on my camel, everything's fine, I know this, and then everything is fire. So I think that is, I would say, my favorite piece of advice is, if you lack a prior knowledge base to connect stuff to, like if I would read a fantastic piece of poetry in Dutch to you, you'd be like, what is this? And I would be like, oh, those culture-hating Americans, why don't they appreciate this fantastic piece of poetry? And then it has nothing to do with you. It has everything to do with you just not knowing any words in the Dutch language. So I think that would be my favorite piece of advice, that you have to make sure that people have access to the right knowledge, that they first have this knowledge base of, in language you would say, a few letters, a few words, and then you can make little sentences, and then you can build up. And in programming, that would be syntax, the basic concepts really need a lot of repetition, and only then can you be like, okay, now let's reverse a linked list.
Very cool. Where can our listeners go to follow you or keep up with you and see what you're working on?
Yeah, the best place would be to follow me on Twitter, which is super easy because my first name is super weirdly spelled. So my Twitter handle is just at my first name, at Felienne, with IENNE at the end. My website is equally easy. That's just felienne.com, where you can read about the book, but also about other research that I'm working on. So that would definitely be the best place for people to follow me.
Excellent.
All right, chat, hang out just a few minutes and we'll wrap up the show and continue on the conversation. Thank you, Felienne. Appreciate you coming on the show.
Yeah, you're welcome. It was really nice to join you today.
That was Felienne Hermans. Felienne is a scientist working at Leiden University as an associate professor. Her book, The Programmer's Brain, is out now as a Manning Books early access program.
If you like this episode, please like, rate, and review on iTunes.
Find show notes, blog posts, and more at sixfiguredev.com.
And catch us live each week on Twitch, and be sure to follow us on Twitter.
This has been another episode of the Six Figure Developer Podcast, helping others reach their potential. I am John Calloway.
I'm Clayton Hunt.
And I'm John Ash.
And fade. All right. That Manning Books Early Access Program is unexpectedly difficult to say.
Yeah, I heard it so funny.
So I've got a 5-year-old, and kids when they're born, they're blank slates. No way around it. And being the kid's father, I've experienced all parts of his life. I don't know that there's much that he's experienced that I haven't at least been around for. But I have the hardest time teaching him anything. And I think it comes down to that, to that knowledge base. Like, except for because he's 5, he's got, instead of a 7 part short-term memory, he's got a 0.5 part short-term memory.
Yeah.
So he doesn't even remember the syllable that he just said before the syllable he's working on now.
That is so cool that they can spell out letters and they're like cat in tree, and then you're like, so where is the cat? And they're like, what cat?
Yeah. Well, I mean, like,
so amazing.
he'll be like at. Okay, now put it together. I can't.
Dragon. Yeah.
It's like, you just said it. Why can't you put it together?
Yeah, and it's just because they don't have the big knowledge base, and for them, the knowledge base they still need to build on is letters, not even syllables.
Yeah. So I'm gonna try to work on that knowledge base after this talk, because it, as John could tell you, I am maybe unnecessarily harsh with people that I'm trying to teach something.
Oh, I feel sorry for your 5-year-old now.
We'll say
You probably should. I've shown him more patience than I've shown adults, but it sometimes is a struggle for me.
Yeah.
Yeah,
it is hard. I mean, I'm like a professional teacher, so it is really hard. And keeping your patience, if you have explained something many times, if that's to a 5-year-old or to one of your grad students, it is still like, but I told you this before. And then it is, like I said, if I would read you a few Dutch sentences, you can never remember them because you don't even know how the sounds map to letters.
Right.
And then again, this is not because you're not smart. So yeah, it takes a lot of patience to get that knowledge in. And what's really important is just indeed check what they know. Don't just assume because you pour the knowledge over them like that they can remember everything. Have them repeat to you what you just said so you can see what's stuck, and maybe like half stuck. So that's already a win.
Yeah, I had a former coworker, and I worked with him for several months, trying to help him be a better programmer. And we'd be looking at some code, and it'd be like, okay, if this is true, then output sentence to screen. Okay, so what does that code do? I have no idea.
Yeah, and this can indeed really be because it is so unfamiliar. It's so different from programming languages that they know that it just doesn't stick.
Yeah, I'm not sure what the problem was, but literally months of me spelling out the code, and then, all right, what are we trying to do? What's the next thing?
Yeah.
No clue.
Just got to find out what that mental blocker is and find out what the association should be.
Yeah, I'm not good at social skills.
Yeah, I've got an 8-year-old, and we were watching TV the other night, and there was a commercial on where this animal comes in the window of a car, and he goes, "Oh, reindeer! No, wait, no, that's a moose." I was like, "Actually, that's an elk." He's like, "Oh, I'm so stupid." I'm like, "No, you just didn't know that. You have no reason that you should have known what that was. You were so close with your first 2 guesses that I associate that big animal with horns to one of those 2 things."
That's not what you really said.
No, that is because he is very hard on himself for an 8-year-old.
Yeah,
He's like,
that's tough.
I'm such an idiot. I'm like, no, you just didn't know that. You hadn't learned that yet.
I think I would have been, yeah, you're wrong.
Clayton and I have worked together for several times on several different projects. That is his way of working with coworkers.
Right is right, wrong is wrong. That's just the way it is.
Yeah. And how is that strategy working out for you and for the people around you?
I've gotten a few people to quit.
I'm not surprised.
No, I'm getting a lot better, but there were several. How old am I? Maybe 30 years where it was just true is true, and that's the end of the story.
Yeah, I've said it before, and I will stand by it, that I actually enjoy working with Clayton on projects, mainly because I know that about him.
Yeah, but this is hard to know, and especially if someone in your team is a junior and they might feel very self-conscious around senior people, then this might be just not an effective strategy. That's also actually something we talk about in the book as well, that your working memory can also be filled with other things than thinking about the content. Like if you're really scared, if you're really worried that you're making a mistake, then you're thinking about not making mistakes, which takes your focus out of what you're trying to do. So if you get this culture where people are super sad or like worried to make mistakes, then that could make them more stupid, like for a brief, not forever, of course, you're not destroying them, but in that situation, they might just be really occupied. This is also in job interviews, for example, where you're like, okay, let's reverse this linked list, and then already your brain is like half eaten by, oh my God, I don't want to make a mistake, I want to look great, and then it's not a great context to get the optimal thinking, because your brain is busy with, do I look weird? Do I sound stupid?
Oh yeah,
And then
that side effect is very, very prevalent in interviews. To the point where one of the major contributing factors as to whether we end up hiring somebody or not is just, can they write a for loop on the whiteboard?
Yeah.
Because their brain is just so fried during that interview process that if they can remember that, if they can manage to keep themselves together enough to write a for loop, then they're probably okay.
Yeah.
And then they're thinking during the interview process, wait, they're asking me to reverse a linked list. What is this job going to be like? Do I have to do that from every day the rest of my life?
Yeah, that is sort of the problem with those type of interviewing.
So you said the book is going to be out and complete later this year. Do you have a timeline, or is it all contingent on the way 2021 is going to shape up?
A bit, I think. So the publisher now says spring, but of course they really like to launch live, like at a big conference where they can have a desk where people can buy the physical books. That's a nicer way of making money for them than, hey, it's online, you can buy it on Amazon. So I think they're sort of awaiting how everything goes, but yeah, from my side, much is there already. The first 9 chapters are entirely done, and they're going to production, so they'll be live. So sort of nice if there's a chapter every month or something. So exactly when it will be out in print, I don't know.
Yeah, I'd be surprised, at least in the U.S., if conferences don't return until October at the earliest.
What year?
I think so too. After the summer, for sure.
Yeah. Our
government is saying they can give everyone the vaccine by September, but no one buys that.
Well, how many people are in the Netherlands?
17 million.
Okay.
Which is, I think, less than what you have already vaccinated in the US. But then, of course, we have to share with the rest of the world.
Yeah. Mm-hmm. So, while reading the first, I think it was just the first chapter, but you misspelled a word on purpose.
Is that in the code? Because that was on purpose. Yeah.
Yeah.
I did.
I started to read it, and I was like, like oh.
And then later on.
Yeah, and I saw it the first time, and then I saw it again and again and again, and I was like, okay, maybe I can leave a comment and just let her know about this spelling mistake. And then later on, you were like, you probably didn't even notice. And I'm like, no, I read every character. It's killing me.
Yeah, that's great. But it's like a win-win. So people that don't notice, it's like, oh, that's interesting. I didn't notice. And other people are like, I'm smarter than she is. I did notice. So that's good for everyone. Yeah, so but maybe I should make it less obvious, because I did get like 10 emails. Because of course people like pointing this out. Like, oh, I found a mistake in your book. Not even, oh, I liked reading it. Like, oh, I found a mistake, lady.
Well, so
Or
at
you could have
first-
reading clubs, and then you could look at Clayton's face the minute he comes across it, and you can watch him twitch.
So at first, when I saw it, my first instinct was, okay, well, maybe I'll just make a comment somewhere and then get that fixed, because it is early access, so there's still a chance that there's spelling mistakes and whatnot.
I'm sure there are other spelling mistakes that I didn't put in intentionally.
There's a spot where I think you use it instead of in or is or something like that, but it's not that bad, really. It's the rest of the book's fine. It was just that Mion was killing me. But there may have been a point where it's like, aha, I know more, or I caught the error. But then when it got to the chess story, and it was talking about how like the mediocre chess players were looking at the individual chess pieces, I was like, oh.
I'm a mediocre Java programmer. I focus on things like letters. What an emotional roller coaster, just that one chapter of my book.
Yeah.
That's awesome. Well, all right.
Thanks for the show. Yeah, I have to log off because we're gonna have dinner here.
Yeah,
because
yeah,
now it's 7.
We're approaching the top of the hour. We appreciate you coming on the show. We are about a week out from launching the episode. So if that's okay with you, we will
absolutely.
Clean up the audio and ship it on January 25th, Monday.
Cool. Yeah, just let me know. You can mention me on Twitter as well. I think your account just followed me, so that's easy.
Yeah, we will do so. If there's anything you need from us or anything we can do for you, just be sure to let us know.
To make sure that you have the right link for the book. I mean, it is super easy, but I just put it in the chat just to be sure.
Yeah.
Felienne.com/book.
Perfect.
And my Twitter, well, you found it, so you can mention that in the show notes as well.
Yeah, will do. So with that, thanks everybody. We will raid our friends over at 425 Show, and we will be back this evening, 6 p.m. Eastern, for another episode of the podcast, and be back on Wednesday at 8 p.m. Eastern for live coding. So with that, thanks everybody.
Bye. Thanks for having me.
All right.